Good morning, everyone. How is everyone doing? Um, Great to see a lot of faces. This is the first time I'm giving a speech after COVID. I'm sure a lot of folks are in the online, and maybe next year we will have more in-person audience. My name is Praba Siva. I have been in the IT industry for 25 years. I've been playing various roles, engineering, architecture, digital transformation, data, and analytics in various industries, ranging from auto manufacturing, auto finance, financial services, supply chain, and now in retail. So I work for Target. I'm sure you all heard about Target or you visited the store. We have close to 2,000 stores in the country. We have one of the top 5 visited retail websites. We have close to 100 million guests coming to the digital space. This is one of the biggest player in the retail industry. I basically lead the CDN, GraphQL, and the API platform for the organization. So I'm here to talk about our journey with CDN and how we implemented CDN for Target. I'm actually super excited to present our journey and want to share the experience that we have. Before we get started, here is a brief breakdown. It's always used to have a slide here, so I'm before we get started, here is a brief breakdown of what to expect from me for next 20 minutes. First, I will provide a little context and history of Target and Fastly relationship. Then focus on how CDN fits into the context of API platform as a whole. Next, I will go into the more details regarding how our infrastructure is managed. Then I will go into highlights exactly how CDN allow us to deliver and secure high-performance digital services. And lastly, I will address few highlighted edge computing projects and share our experience. With that, we have been using Target for we have been using Fastly for last 6 years. As I said, we have 100 million guests coming to our sites, and it translates into billions and billions of traffic coming to our website. Basically, we have APIs and non-APIs coming through Fastly to our environment. Fastly sits in the edge and of the API gateway and plays a pivotal role in the overall digital infrastructure. Fastly helps us to maintain a resilient, secure, scalable environment to provide the exemplary guest experience to our guests, both in the digital and also in the store. Delightful guest experience. So just want to give some high-level context on Fastly. I'm sure most of you know what is Fastly and what is the architecture behind it, but I just want to spend some time on the Fastly architecture. Fastly is based on Varnish. I'm sure, like you all know, Varnish. Varnish is based off the open source tool, and Varnish has been there in the industry for like 16 years. All the configuration of Varnish is done through the VCL. VCL stands for Varnish Configuration Language. It is the domain-specific language for Varnish. Basically, because of the architecture, it provides the caching at the edge, like programmable cache at the edge. It provides a lot of flexibility for us because of that VCL, because of the Varnish architecture, and because the way we designed our system, like we come up with this VCL so that we can cache as much as we can in the edge, so that we can get greater response time for all our APIs and non-API applications. So I will actually walk through the 50,000 foot level of our architecture here. Based upon the geolocation, the URL basically resolves to the closest POP, the Fastly POP, and then from the Fastly POP, if there's a hit, like if it takes the information from the cache, we basically get the response in less than 1 millisecond actually. But if you are not able to get the information from the cache from the Fastly, is it a miss or is it the first request? It has to go to the backend. we basically load balance that, Fastly load balances to the fleet of HA proxy that we run. HA proxy is an open source tool which has been there for a couple of decades. It is written in C. It's a very high performant proxy. We have been having a great success in that HA proxy. We have a fleet of HA proxy running in our environment, and we actually run Chef to manage all the HA proxy. It's fully automated to manage that HA proxy fleet. The HA proxy in return, routes the traffic to the API where it runs in our environment. Again, we have multiple deployment model for the API. One of the model is that it could be a standalone VM or a container, or it could be running in a Kubernetes, it could be running in a GCP, or it could be running in a TAP. TAP is environment, TAP stands for Target Application Platform. That's an in-house developed private cloud. We basically provide the runtime for the application. Basically, this is an integral of our hybrid cloud strategy. In the hybrid cloud, actually, we have both public and private cloud, and TAP provides a holistic, cohesive experience for the developer to manage the runtime both in the private and public cloud. Again, it is internally developed application as tool. We are very proud of those accomplishments. As tool, we are very proud of those accomplishments as an organization. So once the request comes from the HA proxy in one of those deployment model, we basically have a Go proxy, which is again another in-house developed tool. It's a sidecar proxy, which actually takes care of all the non-functional requirement of an API. Like authentication, key validation, rate limiting, codes, all of those non-functional requirements are taken care of by the Go proxy. Again, that is written in-house written Go proxy. It is used. Go proxy is written in Golang. So that is a non-functional requirement. Once that all the non-functional requirements are done, then developer basically develops the functional requirement of that API. So this actually provides greater flexibility for our developers, right? So they have to just focus on only the functional requirement of the APIs, and the non-functional requirements are taken care by this architecture. So because of the flow that what I mentioned here, like we have a greater response time. Like as I said, like if we get the response from the Fastly, we basically get in a single-digit millisecond response time. But whereas if it goes to the back end, it will basically take close to 200 milliseconds. So you can see the response time, how we are able to manage. And as I mentioned earlier, we're talking about billions and billions of requests, and this kind of response time is very essential for us to provide that exemplary guest experience. So the same architecture what I talked about for the API is also applied for the non-API applications. Right? There are a lot of websites that we have which is not specifically attached to an API. Like we have those non-API applications. Basically follows the same architecture. Like we have the slew of HA proxy and a load balanced by Fastly, and then again it can go to the backend application that is running internally in our intranet. So the another flexibility that we get from Fastly is that the load balancing can be done between our private and public clouds. Meaning, like if the traffic is completely running in our any cloud provider, so we don't need to come to our environment to go to the cloud. Basically, the Fastly can route the traffic directly to the GCP, any cloud provider. And to make it the more complex scenario, like we can also load balance between the public and private cloud also. So again, it provides greater flexibility to meet all the latency requirements that what we have in our environment. So I will actually talk about the deployment model, how we are managing the changes to our environment for both APIs and non-APIs. So like for all external facing APIs, like we have URL assigned to it. Like we basically have a single URL, like api.target.com is the one that is available. We want to keep the API specific configuration as minimum as possible. Then all the configuration that what we have, the VCL what we have is all stored in a GitHub repository. Then the whole automation of deploying that VCL to the various POPs can be done through the CI/CD pipeline that what we have developed. So the CI/CD pipeline that what we have is Vila. Again, it is another in-house developed tool, the CI/CD pipeline, which is again integral for all the automations that what we have in our environment. And we have the Vila configuration. Basically, what it does is like it validates all the VCL and then pushes to the POP. I will again go into the detail how we are doing that, because the automation is very critical for us to make that change, that what we want to do to provide that experience, the guest experience. See, Fastly provides a service called Fastly Provider. That is actually service that is running in Fastly for us to connect through our automation. So we basically have all the Terraforms that is stored in the CI/CD pipeline. We basically have a YAML file which actually lists all the various steps that what we need to do for the pipeline. And then the Fastly Provider, the plugin that is given by Fastly, actually helps us to connect to the Fastly. So that is basically the connecting point where our pipeline can connect to the Fastly and pushes the code that is required for making any changes in the environment. So again, this is a life cycle, like what exactly happens, how the code gets pushed and activated in Fastly. Basically, we do a pull request, then in our CI/CD pipeline. Then the Vila file that I mentioned basically will have all the exact steps that what we need to do. We basically run that CI/CD pipeline where it validates all the VCL. It will make sure that all the configurations are meeting all the requirements, functional requirements, non-functional requirements of the VCL. And we will be doubly sure before even we move to the CD, which is the part that I mentioned in the previous slide, where we use the Fastly service and push that VCL into the Fastly environment, and then Fastly does the validation on Fastly side before it gets activated. So there are various steps involved. In every step, we basically validate in the VCL so that we don't have any error in doing that life cycle. So again, just to summarize the overall deployment of the VCL in our environment, like each application has an association to the GitHub repository. So we basically have a one-to-one relationship to the VCL. So there is no overlapping of VCL between APIs. It actually provides a lot of flexibility. Then once the VCL, there is a pull request, then the CI/CD pipeline gets kicked in, and it does all the triggering part and validates in the local environment. Then the CD part comes in where it pushes the code. Then then there is a validation done there, and then it gets activated in the Fastly. So this the whole life cycle that what I talked about, like how the VCL from inception to deployment and activation, it all can happen instantaneously, like in a very faster manner. And we have automated the whole process in our environment. So for our non-APIs, like we have the same process, same one-on-one relationship to the GitHub repository. But for the non-API applications, we don't have a lot of configuration for the non-API applications, right? So basically what happened was like we ended up having too many repositories. So we actually consolidated all of them into one single repository we call bridge service. Like if we have any intranet application that we want to enable in internet, we basically follow that bridge services, and it can instantaneously again enable it in the internet. So if somebody our developers, our partners, internal partners, our team members who wants to enable an intranet application to an internet, like through the bridge services, basically they can enable it by following this process. So the advantage what it has provided to us is that because the way we designed or architected our end-to-end deployment, we basically follow the consistent process across the team. Like if a developer or a team member moving from one team to another team, they basically know exactly what is the process for them to move the VCL. We have a consistency, but at the same time, we are not limiting our developers to be constrained. Like we have provided a lot of autonomy for the developers to make changes to the VCL and then move it. Because of this end-to-end automation, it provided a lot of flexibility for the application team, and we are very rapid in responding to any business and non-functional requirement that comes on our way. There are a few other examples that how we implemented automation in our environment. So some of the team members, like they are not well versed in the VCL, and because they do use it very rarely, so we don't want to force them to learn the VCL because they don't use it often. So we actually have created a generator, VCL generator, like they can go and put their requirement in a JSON file, and then that generator basically creates a VCL for them. So that is one of the automation that we have. And the same thing, we have for the certification, renewals, subscription. So again, we have greater automation in that space. And also the Fastly service to redirect the external domain aliases. Again, it is a simple one-line change in the dictionary which will enable that also. See, I talked about the various steps in deploying the VCL in our environment and how we are doing it by automating it by the CI/CD pipeline, the VLA pipeline, the configuration, the YAML. So in each of those steps, we basically take the security very seriously and implement the security requirements in every step of it, right? So we have a compliance team, we have a security requirement. We want to make sure that every changes that what we make in our environment is adhering to all the security and compliance requirement. And we don't want to burden our developers, our team members to know all the security requirements comes from our compliance team. So what we do is we have created a lot of security comments. So it is not necessary for each one of our developers to learn all the security requirements. They basically have to include that dependency in their VCL. All the requirements can be automatically included in it. And again, we validated it as part of our CI/CD pipeline in every step that I mentioned earlier. Then in the pre-prod, pre-production, basically again it is implemented in the YAML file, the VLA YAML file that I mentioned earlier. We basically validate all of them, and then we do a dry runs, meaning all the Terraforms that I talked about, the connectivity, the infrastructure changes. We basically have a preview before we push it. Then again, in the Fastly, there is another validation happens, and then it moves to the production and all populated into all the POPs. But in spite of all the security measures that we have, if we find we have to roll back, then again, we can roll back very quickly by click of a button to go back to the previous version. Just to summarize some of the best practices that we have in our environment, dry principle, don't repeat yourself. That's why we have all these common security common and various common VCL stored. Once it is done, we don't need our developers to learn every time. Then the phase lifecycle plan that I talked about. Then also we have a SIG, a special interest group within our organization. We'll do a lot of inner sourcing, part of that SIG. We have a lot of collaboration among the various users within the organization who uses CDN and the VCL. And segregation of concern, as I mentioned, we have a separate Git repository for each one of the Fastly services. So it actually provides a lot of separation of concerns, and also we have a lot of abstraction that I mentioned. Not each one of our team members has to learn and understand all the requirements that we have in our environment. So because of this automation, because of all the life cycle that I've talked about, because of the security steps that we have in each step of the automation, we actually provided a lot of flexibility for us to innovate. So we recently completed a pilot and then we moved that pilot into production using compute at edge. So the purpose of this pilot is to basically detect the bot traffic coming to our site and prevent it. So we actually implemented this by using Rust. We tried with JavaScript and we noticed that the response time is not meeting our requirements, so we quickly moved to Rust and it is running in Rust. So it basically look for a bot and prevents the bot. And there are a few other use cases that I can share with you. So because again, the foundation, what I talked about, actually provides a lot of flexibility and innovate. The similar kind of concept, like once we detect some DDoS, again we are running this DDoS mitigation tool. It actually can quickly drop the traffic based upon the pattern that what we analyze through other means, other reports that we get. But once the traffic is identified that this could be a potential DDoS attack, like we can, we have implemented a DDoS mitigation tool that can be executed in the edge. Will do that. Again, the dependency manager and the custom log, field logging. These are some of the other examples that what we have done in the edge. Some key takeaways from this. There is we have a separate repository for each one of the application, which actually provides a lot of flexibility. Then we have split this monolithic VCL that we used to have in the past, and actually provided a lot of separation of concern that I talked about. The end-to-end automation that what we have, which actually eliminates all the human errors and other overall risk. The automation provides a lot of flexibility for us. The edge computing provides an opportunity for us to be more creative and innovative on how we can come up with new applications in the edge. And because of the implementation that we have very high hit rates. Like as I said, the response time is single-digit millisecond if it goes to the cache, comes through the cache. Because of this, like we are reducing a lot of traffic going to the backend, so it also reduces our overall cloud cost because of that. And also, like it provides faster response time because it's coming from the cache. So with that said, thank you.